Let's start the discussion about compound microscope. Now, you guys have already learned a simple microscope, right? A simple microscope is basically just a magnifying glass. Now, this is basically a compound microscope. If you look at it, a compound microscope has two magnifying lenses, correct? So now let's look at the setup as to how exactly a compound microscope works, right? Okay, so you have two lenses. One is an objective lens, one is an eyepiece. Now, both objective and eyepiece, both of them are placed on the same principal axis. This is first thing. And the second point is objective lens is smaller compared to that of eyepiece. So when we say smaller, we basically look at the focal length. All right. So now you have FO as the principal focus for the objective and FE as the principal focus for the eyepiece. So we can call that F naught as the this one focal length and FE as the focal length for eyepiece. All right. Now, an object AB is placed beyond F naught. So let's call the distance as U naught. All right. Now, a ray of light from AB hits the objective. Since we are keeping the object beyond F naught, it's going to form a real inverted image. So something like this. So A dash B dash is the image of AB. Now, as you can see, it is real, inverted, and magnified. Correct? Now, so let's call the distance, that is the image distance, as V naught. All right. So see, if you look at this, A dash B dash serves as an object for the eyepiece, correct? Let's say UE is the distance. All right. Now, this particular object, I mean, we are talking in terms of the eyepiece now, with respect to the eyepiece. A dash B dash is the object. So this is placed between the pole and the principal focus, correct? Since it's between the pole and principal focus, it's going to form a virtual image, correct? So basically, you will have diverging rays of light, which forms another image, which is A dash B dash. Now, if you look at it, it is virtual, it is erect, and it is highly magnified, right? So this distance, let's call it as D. Now, if you look at it, D, that's nothing but VE, correct? The image distance with respect to the eyepiece, right? So now you have U naught, we have V naught, which is the object distance and the image distance with respect to the objective. Next, you have UE and D. This is the, again, object distance and the image distance with respect to the eyepiece. All right. And you obviously you have F naught and FE, which is the focal length of the objective in the eyepiece. Let's come to the magnification of the compound microscope. Now, coming to the magnification done by the objective, so we have M naught is equal to, so since we have the image distance by the object distance, we can write this as VO divided by UO, where VO and UO are the image and the object distance with respect to the objective lens. All right. Then we have the next lens, which is the eyepiece. So say ME is equal to VE divided by UE. All right. So the net magnification, so we can call it as M is equal to M naught into ME. So this is what we have as the net magnification. Now, so if we have to calculate, now MVO by UO, that's the magnification, that's well and good. But when it comes to VE and UE, we can write the same thing in terms of the length of the tube and focal length and everything. All right, so let's come back to that one. Now, what we know so far, we have the lens formula. So lens formula is given by 1 by F is equal to 1 by V minus 1 by U. So if you are doing this for the eyepiece, you have 1 over FE is equal to 1 by VE minus 1 by UE. Fair enough? Now, what do we know so far? The same formula can be written in another way also, which is VE divided by UE is equal to 1 minus VE divided by FE, correct? Now, VE by UE is basically ME. So, if you substitute that, so we'll get this as ME is equal to 1 minus VE divided by FE, right? Now, if you apply this and remember how we define VE and FE in the figure. So, we have VE is equal to minus D, correct? So, where D was the distance. Next, in this case, FE will become plus FE, correct? Applying the sign convention, the Cartesian sign conventions. So, if you look at this, then the same formula ME will change to 1 plus D divided by FE, correct? So, this is ME. Next, we already know what is MO, the magnification by the objective. Now, if you combine these two together and if you write it, then the magnification M becomes MO, which is VO by FO, sorry, VO by VO. So, you'll get this as VO divided by UO into ME, which is 1 plus D by FE. 1 plus D divided by FE. So, this becomes the formula for the magnification of a compound microscope. Now, see, what we do is we can approximate few things and we can write in terms of the length of the tube. Alright, so what we have is this VO is approximately equal to L, where L is the length of the microscope. And you can also write UO is approximately equal to FO, which is the focal length of the objective. So the two approximations what we are doing is, one is VO is almost equal to L, where L is the length, and another one is UO is almost equal to FO, where FO is the focal length of the objective. Now, if you do that, again, we'll have to apply the sign convention here. So, we get the magnification M is equal to minus L divided by F naught into 1 plus D divided by FE. So, this becomes the formula for the magnification of a compound microscope.